Hi everyone, in this lab, let us run through the Spark job on the data pipeline that we have created so far on the Amazon EkS cluster. Let's get started. So we will take a simple application. We will read the file from the S3 bucket, okay, and the input file is in the format called Apache Forget, and then we will do some simple operations. For example, creating a data frame object using the Spark Python library, then adding a new column to this particular data frame, and then count the number of records in this data frame. It's a very simple application, and so we will repartition this data frame into two partitions and write into S3. Okay, so a simple transformation like this, we will showcase how to run using the DAG and Airflow, right? So the input and output are in the Amazon S3 bucket and the format is Apache Forget. So let's get started. Yeah, so in this lab, let us deploy a simple Spark application which is called taxi trip that we discussed earlier. And for that, first we need to copy the YAML files, which is a Spark application, and the DAG file. So let's look at the DAG file. It is a simple configuration. If you look at it uses some Python libraries for Airflow, and within the Airflow module we have two important functionalities. One is Spark Kubernetes operator and Spark Kubernetes sensor. So we use Kubernetes operator to submit the Spark job in the task 1, and here we are providing the YAML file path, which is the job update. We will look into that in a minute into this namespace. And in the task 2, we are using the Spark Kubernetes sensor to verify that the job is complete or not, monitoring the status. Okay. Now, if you go to the job update, it is a Spark application CRD, which is Spark operator will understand and convert that into the driver and the executor parts. So it is using basically the public Spark runtime image, Spark operator image 3.2.1 from ECR public repo. So both the executor and the driver parts. So this is the Spark configuration for Kubernetes. So we have configured the Prometheus for monitoring, and if you look at the driver pod configuration, so the number of cores, CPU memory, labels, and I've commented out the node selector and tolerations for simplicity. So that means it can run on the default node groups which are on demand. If you have any specific requirement, for example NVMe disk or specific node types, we can use those labels and tolerations accordingly. Or for example spot instances, normally we recommend to run on the for the executor parts. So we can use all of these Kubernetes scheduling constructs to do that, but for the simple test I've disabled all of that, commented out them. So it's a simple application which runs on the on-demand for both executor and the driver parts. So let's go to the Airflow UI and trigger the job. So this is the Airflow UI. So we have multiple DAGs already available. I've tested a couple of them in the past, but right now for this test I will do the PySpark taxi trip default DAG. So I'll simply trigger this using the trigger DAG. So you will see that it is in the running mode. Now we will go to the console and check some logs, right? So right now there are 5 nodes. I'm using the EkS node viewer binary to view the CPU memory consumption on this node. So there are 5 nodes which are on demand from the managed node group, and quite a few pods are already running there, and this is the instant type. Now this is my number of pods in the namespace, right? I'm waiting. So the Spark operator should create the driver of the executor pods in this namespace. Okay, and this is the Spark operator. So it received the request, and you should see now the pods getting created in the namespace. The driver pod should be created first, like we discussed in the past. So let's wait for a second. So the driver pod is created, and also the executor pods are created. All of them are in the running state because we already have the EC2 nodes available to run this driver and the executor pods. And like we discussed, they are all running on the node managed node group nodes. So it is straightforward. So we are not using Carpenter for this demo. We can definitely use that separately to trigger the nodes based upon the requirements. But this is a simple configuration. So let us wait for it to complete. I'll take a pause. It might take 1 or 2 minutes depending upon the requirements configured for this job. So the job completed now. It took around 2 minutes or so. Now you see the executor pods are getting terminated, and then you will also see the driver pod in the completed state. So the job completes. So this is how the Airflow is triggering the DAG. Using that, the Spark operator is receiving the Spark application CRD, which in turn will create the executor and the driver pods to complete the job. ID and see how much of time it takes for various stages. So these are all the job IDs and the duration, the stages, all of that is available here. So if I go to the stages tab, and I can see different stages, and each stage will have an ID and also the duration it took, and there is a shuffle read, shuffle write, how much of memory is required and time required for all of that, we can analyze. Okay, so with this we conclude the testing of a simple Spark application in the open source based data platform on EkS.